This episode of Photonics Hot List is brought to you by Luna Innovations, enabling the future with fiber.
Hi, I'm Justine Murphy, Senior Editor of Laser Focus World. Let's take a look at what's happening in photonics. According to the World Health Organization, nearly 250 million cases of malaria were reported worldwide in 2020, and more than 600,000 of those people died. Eradicating malaria has been front of mind for medical researchers for decades, but that's complicated by those who are asymptomatic and can act as a reservoir for transmission of the disease by mosquitoes. But now, researchers at the University of Queensland in Australia are on the right track toward eliminating it, with the development of a light-based detector. The new technology is non-invasive, unlike conventional methods that require needles to draw blood. It's a handheld, smartphone-operated near-infrared spectrometer that shines infrared light on a person's ears, arms, and fingers for about 5 seconds. Malaria infects red blood cells, causing structural and chemical changes. This new technique collects an infrared signature on what's in those cells and the bloodstream. With the results from the spectrometer, a predictive computer algorithm can differentiate infected from uninfected people. Once the new system is fully validated, following an expanded proof-of-concept study, it could be used for universal surveillance of malaria and guide existing efforts to eliminate it. Autonomous vehicles and their LiDAR systems are advancing rapidly, but there are still kinks to work out, specifically relating to security. Researchers from the University of Florida, the University of Michigan, and the University of Electro-Communications in Japan have discovered an issue with LiDAR sensors that could have very serious consequences for autonomous vehicles if attackers were to get in. Using laser pulses, LiDAR sensors calculate the distance from the sensor and the potential obstacles in the vehicle's path based on the timing of returned signals. The researchers note that in the real world, these signals are noisy, so the sensor prioritizes them. But if a signal, like a close reflection, is returned too fast, it's filtered out. Attackers could exploit this behavior by generating laser pulses that mimic fake returned signals closer to the LiDAR sensor. It essentially tricks those sensors into discarding that data about pedestrians and obstacles. The researchers are looking at other sensor technologies now to better understand LiDAR's security vulnerabilities and ultimately prevent such attacks. Inspired by a challenge to provide food for 10 billion people by 2050, a team at the University of California, Davis is thinking outside the box toward possibilities for food energy cogeneration and to boost land efficiencies and farmers' resilience. Light is a resource that can be sustainably harvested, so the researchers are working to better understand how water, soil, plants, and climate respond to different light inputs. Their goal is to introduce solar radiation as a resource rather than a classic boundary condition in agriculture. Optimizing light as a resource maximizes its utility and allows photosynthesis to generate energy. The researchers have developed living plant biosolar cells using a succulent known as an ice plant that runs on photosynthesis. In their study, they inserted an iron anode and a platinum cathode into one of the plant's leaves, which produced nearly half a volt of energy. When connected to a circuit and also exposed to light, the plant could produce even more photocurrent density. The energy generated with that one leaf isn't as high as what a traditional alkaline battery can carry, but repeating the process throughout all of its leaves could increase the voltage for development of more advanced sustainable energy technologies for agriculture. And that's your Photonics Hot List. Be sure to like and share and subscribe to our YouTube channel for more Hot List videos, expert interviews, and other cool content. And on behalf of all of us at Laser Focus World, have a safe and fun holiday season. We'll see you in 2023.